Good afternoon. My name is Kareem Shishakli. Welcome to our next webinar on Stella's new AI assistant. This will be presented by Billy Schomburg, who is our lead developer and has a PhD from the University of Bergen in Norway. Billy is the developer of our Loops That Matter feature. How it works is in his PhD dissertation. And Billy has also implemented all this AI stuff that we have been talking about for more than a decade about adding to Stella. And he has also gone on to add some new things like Selden and the mentor that he will talk about during this webinar. Billy.
Thank you, Kareem. I'm so happy to be here with you all today. And I just want to start with the boring stuff, the mechanics of the webinar. We're using GoToWebinar here, and there's a little grab tab on the left-hand side of the screen that lets you hide or display the panel, and it's important because that's where you're going to enter any questions. And if you can't hear me in the audio setup part is where you can set up your microphone and speakers. A part of this webinar, we're actually going to do a discussion, and so to be called on in order to be unmuted, you'll want to hit the raise hand button. So without much ado, let's get into today's topics and what we're going to learn about in today's webinar. The first thing we're going to talk about is how to leverage AI in the modeling process. We're going to talk about different kinds of models, both qualitative and quantitative, although frankly, I'm going to focus on quantitative modeling today. And we're going to talk about how you can use AI in all different parts of the modeling process, from ideation to building, to fixing and debugging, to understanding, and to policy analysis. From there, we're going to move into that group discussion that I was talking about a minute ago. And then we'll go into a full-on Q&A session. So to make sure that we don't get ahead of ourselves, I want to start at the beginning. The beginning for me is the modeling process. All of these tools that we're talking about here today that leverage artificial intelligence don't change, throw away, modify, or otherwise deprecate this modeling process. These tools that we're talking about help you to perform certain aspects of the modeling process either faster or better or in different ways than you have in the past. But the modeling process is still sacrosanct. The human is still at the core of building and analyzing and understanding and communicating models. So in the modeling process, we start with the reference mode. What's the problematic behavior we're trying to solve? From there, we move into a process where we develop a dynamic hypothesis, some causal explanation that might explain why we see the problem. From there, oftentimes, we move into building stock and flow models that quantify that dynamic hypothesis. And then we work to verify that quantitative model against the reference node. Hey, does this model actually reproduce the problem? Does it do it for the right reasons? Is this a model that I have any confidence in? From there, you move into analysis in the form of sensitivity or certain kinds of optimization. And then we move into policy experiments. Now, I've presented the method here as very linear, but those of you with experience know that it is highly iterative. Oftentimes, as you start building a model, you start making changes to your dynamic hypothesis that then cause you to build different structure in your model. When you go to verify the model against the reference mode, you might find problems that change your dynamic hypothesis that then change the stock and flow model. Likewise, when you analyze, you might learn something new that may even cause you to do something back at the reference mode stage. So we're going to talk about how AI can be used in each one of these stages to kind of help you along and save you a little bit of time or help you do that much better of a job. So let me introduce you to the gang of assistants that we're going to be using today. And they're called the qualitative engine, the quantitative engine, and Selden. So you hear me putting like this word engine at the end, and that all references what's called the SDAI platform. It's an open source project that myself and some folks at IC Systems, as well as some folks at Skepticism, started to share this technology with the community as opposed to and cooperate, as opposed to compete to develop this stuff. So these engines are algorithms that exist within that platform. So the qualitative engine, that's for building CLDs. The quantitative engine, that's for building stock and flow models. And Selden is pretty neat. Selden is a pretty cool dude, named after Harry Selden, the greatest dynamicist to have never lived. Selden is a discussion engine. It's a bot that you can talk to your model about. And we're going to make pretty good use of Selden here today. You're going to see that there are many different suffixes assigned to these engines, like mentor and experimental. So mentor is an engine, either quantitative or qualitative, or Selden, that makes sure to ask you questions. You know, the goal of the mentor engine is to help you expand your thinking, critique your work, and kind of push you into digging just a little bit deeper. Whereas the versions of the tool without mentor are much more like task agents. They do exactly what you ask for, nothing more, nothing less. Mentor tries to push you a little bit, get you thinking. Experimental is for the researchers among you. There's no reason why it's only me or only software engineers who can do research using these tools on how to develop better tools. The experimental version of any one of these engines opens up all of the system prompts and all of the structure that you can then actually edit directly inside of Stella to become your own AI researcher. If you find better system prompts or better prompting techniques, please let us know in the SDAI project so that we can take your work and incorporate it into the work of this collective. So let's talk about how we can develop a dynamic hypothesis using AI. And there's a couple of techniques that I'm going to talk about leveraging. And these techniques come out of the the AI in SD Education Task Force. And I'll give you a link to that at the end of the webinar. And the first technique that we're going to talk about is using the AI to help refine a strong problem statement. So defining your problem and making it very clear is very important when you're building models, both as a human and with the assistance of AI. So for instance, you can give a prompt like, I'd like a 2-sentence problem statement. I want to develop a model about the causes of the American Revolution, for instance. So you'll see there that I was very specific in what I wanted the LLM to do. Next, another important technique is use the AI to generate context that can be validated and then inserted into the later stages of model construction as background knowledge. For instance, give me a bulleted list of concepts and relationships that I should include in my model. So these tools work best when you use them to transform information from one format to another. You don't really want to rely on the LLM, large language model, the AI system, as the progenitor of knowledge. Instead, you want to use it for what it's designed for, which is to transform information from one context into another, from prose into a model, or from model into prose. So by generating a bunch of background knowledge that you then validate and correct, you then give the LLM something to work with when it starts helping you to build your models. Finally, you want to be very specific about your audience and the complexity of the intended result when you prompt. For instance, give me an explanation, meant for a high school student about the causes of the American Revolution. So let's put some of this into practice. So here I am inside of Stella, and I've got some of those prompts already done. I'm trying to save a little bit of time as we wait for the LLM to respond. So for instance, I said, I'd like a 2-sentence problem statement about the American Revolution. Here's the reply, and here's the 2-sentence problem statement. So I can take that, and I can put it into the assistant-specific inputs for Selden, right-click, and paste, and now I have a problem statement that goes along with every request that I make to the AI, to the discussion bot. For those of you who are following along, I got the virtual assistant by going to Window, Open AI Assistant Panel. The next thing I sent to the LLM was, give me a bulleted list of concepts and relationships that I should include in my model. So I can take all of that background knowledge and concepts and copy it directly out of the log. Trust me, I have read through this and make sure that it is accurate. Okay, So I'm going to move into the build mode, and I am going to paste that into the background knowledge. Likewise, I want to take the problem statement, I want to take the background knowledge and the problem statement. I want to put them both into Selden. So here's the background knowledge, and here's the problem statement. And now what I'm going to turn around and do is I'm going to ask Selden for help in coming up with prompts that I could give to an AI to build the rest of this diagram. For instance, the one give me an explanation meant for a high school student. I messed up. Anyway, the point of doing something like this is it gives you information that you can feed into the LLM in order to get the LLM to do a better job. You don't want to try and one-shot a solution. You want to do something in smaller bits and pieces. In fact, I'm going to abort this request because what I intended to do was not ask Selden for an explanation, but instead to ask the qualitative engine for an explanation of the American Revolution based on the background knowledge and the problem statement. I apologize for the confusion. So I've put the problem statement into the assistant-specific inputs for the qualitative engine, and I'm going to take the background knowledge and I'm going to put it in here, and now I'm going to submit. I apologize. So what this is going to do now is this goes off and communicates with the SDAI platform. The SDAI platform is an open source project, like I said, started by some of us at IC Systems and some of us at Skip Design, that interacts with LLMs using a set of algorithms that we've coded. And so this is using off-the-shelf tools from Google in this case. But you have the ability to use different backends. You can use OpenAI LLMs. And even as of last night, you can use Claude as the backend for generating this content. The way that it's doing it is it's using what's called a structured output. A structured output is a contract essentially that gets signed with the LLM, forcing it to return content in a machine-readable format, JSON. That machine-readable format is specified in the format of a schema that describes how information should be passed between the AI system and Stella. That schema contains descriptions of every field that needs to be in the response from the LLM. So for instance, when we generate CLDs, we ask it for a list of relationships, where each relationship has a from variable, a to variable, a polarity, a reasoning for the relationship, and a reasoning for the polarity. Stella, as the client in this system, then makes use of all of this information and displays and plots it for you on the screen. The way that Stella draws the CLD is using actually a force-directed graph, essentially a physics simulation, to figure out how to place the content on the screen. You'll notice that sometimes requests to the LLM take a little while to complete. Like I said, this is because it's not something that's running locally on your machine or even running on IC Systems servers. This is the same Gemini that you use if you're on your Android phone or if you're on the Gemini web client. So in periods of high use, you wait. Likewise, another thing that's important to realize is because this is based on LLMs, which are stochastic, there's a variability that's injected in this process. Doing the same request twice in a row, or even separated by 2 or 3 days, doesn't guarantee that you get the same results. In fact, oftentimes you get very different results based upon the time of day, the level of usage, and frankly, butterflies flapping their wings in South America. There is variability in this process. This request is particularly long because I've given it a bunch of background knowledge to chew on, and likely we're entering a period of high usage because people on the West Coast in the U.S. are now up and fully at work. So now we're kind of at the whim of Google and its availability. Something that's important to realize that when you communicate with these tools inside of Stella is that they are a bit different than ChatGPT or other agents that you use on the web, in that it's ultimately stateless. The only information that the LLM has access to is what is present on the screen at that point in time. By that, I mean the LLM knows all about the structure of either the model or the diagram that you've generated. Likewise, it knows about any problem statement or background knowledge or anything in the assistant-specific inputs that you've given it. And it knows about the prompt that you've put into the virtual assistant. But it does not know all about the reasoning that exists here in the log. So this was an example of generating probably way too complex of a CLD in one shot. We didn't follow some of the good rules of working with AI tools, which are the same good rules as building a model as a human. Those good rules are to break your problem down into small iterative steps and work piece by piece to build a diagram. So we can step through in the CLD loops panel the 40 feedback loops that the LLM generated for us, and we can begin to validate if any of them are useful and ones that we want to work with. Likewise, we can hover over any of the connectors and see that reasoning and polarity reasoning, and we can click on the connector and go into the documentation and see that information presented here. Likewise, if we had entered in our own documentation, we would be able to use, or the LLM would be able to have access to that and use it to make future suggestions. So let's move on from CLDs and dynamic hypotheses, and let's talk about using AI to help with ideation. Let's talk about two techniques that we can leverage, in addition to those already shown, to help come up with ideas. We're going to use the AI to break modeling down into smaller tasks, and we're going to use the AI to suggest prompts to use to build the model. And we're going to ask it for 2 steps that can be used to build a sysdynamics model with a problem statement. Each step should add to the scope of the model and result in a running model. For each step, give me a 2-sentence prompt I can give to an AI to build me that part of the model. So here I'm being very specific about what it is that I want. So let's switch back to Stella and let's make a new model. We'll go to the virtual assistant, and now you see that we're talking to the quantitative engine. I'm going to switch to quantitative mentor so that we can see how the mentor asks us questions to expand our thinking. The problem statement that we're going to work with is one that I'm pulling in here. I'd like to understand the dynamics of overshoot and collapse with a non-renewable resource in an ecological context. And in fact, we want to start by actually getting steps for how to build this model. So let's put the problem statement in for Selden. Next, we're going to take the actual prompt that we came up with. Give me the 2 steps, and we're going to submit that. What that's doing is it's asking Selden to help us come up with ideas for how we can model this process and ideas for how we can separate this process into small bite-sized chunks. Because you just saw, when you have the LLM generate something really big all at once, it'll do it. But then you don't really know if it's generated something that you can trust, that's useful, or based on anything of real significance. So that's quite important. Recognize that an LLM will do everything it can to answer the question that you ask it, regardless of whether or not that question is actually answerable or relevant. So oftentimes, I like to check that the questions I'm asking are actually the ones that I intend to ask. So you can see here now how Selden gives a somewhat long-winded response about the 2 steps that it wants us to follow to build this model. It then comes up with a prompt, which I'm going to take here. And then it talks about including environmental degradation into the system. so that instead of building environmental degradation into our basic overshoot and collapse with a non-renewable resource, we're going to first build the non-renewable resource and the population stocks, and then if we want to and we have time, we can come back and add pollution. So I'm going to move over from discuss into build and into the mentor, and I'm going to paste that prompt. I am then going to take the same problem statement and give it to the quantitative mentor. And I'm going to then submit this request to build this model. The quantitative mentor now has access to the problem statement and the prompt I've given it. It knows nothing about these future steps. That information isn't in its context window. That way, it's not getting confused about what's going to come in the future. So in this case, now we're using the LLM to actually come up with a model structure. It's going to build for us the stocks and the flows and the connectors. Likewise, it's also going to come up with an explanation for that structure that critiques it in real time, that asks us questions about that structure that's designed to kind of further and expand our thinking. The lines of critique that the mentor engines take are based on the context. So the quantitative mentor focuses a lot on right behavior for the right reasons, focuses on do all of the stocks have all of their inflows and outflows properly represented. The mentor focuses on units and dimensional consistency, as well as the overall scope of the problem. Does the model actually represent the full scope as implied by the problem statement? The engine works in much the same way as the qualitative engine works, but in this case, the structured output is different. The structured output for the quantitative engine has not only a list of relationships in it, but also a list of variables, as well as the simulation settings. The simulation settings that the LLM has access to is the start time, the stop time, the DT, and the time units. Likewise, for each variable, the LLM is able to determine its type, its equation, any inflows or outflows if it's a stock. If it's a graphical function, it's able to generate a graphical function. It also always generates documentation and units. This means you can use AI tools to document and fix units in pre-existing models. There's no reason why you need to use the LLM only on models that the LLM has helped you to build. These tools have been built in such a way that they support this kind of iterative workflow. The tool always has access to the model that's on the screen, including all of its equations, documentations, units, etc. So in this case, you can see again that we're waiting a little while for the LLM to respond to us with a model. I expect the model that comes out of this process to have two stocks, the population and the non-renewable resource, and for them to be connected by a graphical function that modifies the birth rate and the death rate of the population based upon the level of the non-renewable resource. From there, we're going to start talking about how we can fix some of the problems that exist in models generated either by the AI or by humans. Excellent. So in this case now, we got a model generated for us. And the diagram generation process isn't always the best, but it is at least functional. So I'm going to take a moment here, and I am going to kind of reorganize this diagram just as a way of gaining a little bit of familiarity with the model that it has built. So we can see that we have our population with our births and our deaths. And if we hover over population, we can see that it's 100 individuals. And if we go into the documentation, we can see that it is now a documented variable. Every connector has polarity, as well as the reasoning and the polarity reasoning. Every equation has units. I picked a flow here, which is a little boring, but you can see here that the stock has units. We can see that graphical functions were actually generated for us. And in this case, it's done something pretty special, something I don't see the LLM do quite often, which is it actually normalized its input to the graphical function. It's not using a dimensioned input. Most of the time, the LLM messes that up and uses dimensioned inputs. We can see that there are no unit errors in this generated model. And we can see the critique that the quantitative mentor has come up for us. So it asks us to think about missing scope and missing variables. The model only focuses on the interaction between population and a single non-renewable resource. Are there other critical factors that influence the population dynamics and an ecological concept that are not included? For instance, what about food availability, waste accumulation, pollution, disease? How might these things change? For instance, are there any missing flows and stocks for the population? Does migration play a role? For the non-renewable resource, could there be any process that effectively extends its availability, such as technological advancements or things like that? Likewise, it points out assumptions that exist within the graphical functions, critiques the right behavior for the right reason, and it talks about the resource as a homogeneous quantity. Is that what we actually intend here? It then gives us a summary of all of the connections that it created. So in this case, we can now go ahead and run this model, and we can see that we get our overshoot and collapse, but we have a problem. Our resources go negative. That doesn't make sense. So that brings us to the next step in this process. How can we use AI to help fix a model? So what we always want to do is run the model after the AI has returned model content. We want to read the explanation of how the model was constructed. We want to check for negative stocks when there shouldn't be, graphical function form, and equations with embedded constants. LLMs can sometimes be crappy modelers and hide magic numbers inside of equations. Be aware. So we're going to use AI to help fix this model by using the prompting technique, prevent stock from going negative by taking action related to an outflow. So this is a very common form that you can use in your work with LLMs. Do some behavior related to some variable by taking some action. In our case, we're going to do that by saying, and I'm just going to do quantitative for this because I don't want a whole critique of the model. Prevent non-renewable resource. In this case, I did spell it right, but for those of you who aren't good spellers like me, minor spelling errors inside of prompts doesn't really tend to affect things. Likewise, if you want to generate models in other languages, Spanish, Turkish, whatever, if you prompt in that language, you will get models in that language. So we want to prevent non-renewable resource from going negative by limiting the resource consumption flow. So we've now given it a very specific instruction about what we intend. And I expect that the system is going to fulfill that instruction. It's going to go through. Likely, it's going to end up making a little graphical function that limits the resource consumption based on the amount of the non-renewable resource. The other thing it might do is change the shape of the graphical function on the resource impact consumption to be a little bit more stringent to limit the amount of consumption when the non-renewable resource gets lower. But we'll have to wait and see. In this case, the LLM is operating off of the model structure that's present within the system, as well as the prompt and the problem statement. It doesn't have access to any of the critique from the quantitative mentor. But you should feel free to oftentimes take information that's being given to you by the AI and put it into the background knowledge. So in this case, no new structure was added, but existing structure documentation may have changed. And it went ahead and it said it changed the graphical function. And so let's see. We now get exactly what we intended and what we wanted. We no longer go negative. Run 2 does not go negative. So now we can go ahead and move to the next part of this process. The next part of this process is using AI for understanding feedback. And so what we're going to do now is we're going to ask the LLM to explain to us why this model does what it does. So to do that, we need to create a table of all stocks and flows, as well as any key converters, and copy and paste them into Selden. We're going to make sure that we run the model using loops that matter. And then we're going to ask for a feedback-based explanation for X, for some behavior. Give me a feedback-based explanation for why population collapses, for instance. So let's go ahead and do those steps. So we're going to put down a table, and I'm just going to put it willy-nilly on the screen. And I'm going to use the green plus, and I'm going to select, using the shift key, all of the stocks and all of the flows. In this case, the converters aren't helpful, in my mind, to the explanation or relevant. The table itself isn't natively shared with the LLM. Only the stock and flow structure is. So if you want to share the contents of the table with the LLM, you need to right-click, copy. So now I can minimize this. Oh, and we can see that we have some unit warnings. So something that happens with the AI system that's a bit annoying is that the units will inadvertently show as being an error when they aren't actually in error. So by changing the time unit, adding or removing an S, it forces Stella to revalidate all of the unit equations in the model and fix the problem. This is something that we're hoping to resolve before we release Stella Architect 4.1, which we intend to do in the coming weeks. So you'll see here, going back to what I was doing, I took the table, I hit this little cell in the upper left-hand corner to select everything, right-click, copy, minimize the table. I go into the virtual assistant, and I don't want to build my model anymore. I want to discuss my model now. And I'm going to put that table into the behavioral description. I can then tidy up those inputs. And now what I'm going to ask for is give me a feedback-based explanation for the collapse in the population. Because we've run the model using LTM, Selden now has access to all of the LTM metrics that are computed inside of Stella, including how dominant each loop is at each and every point in time, and the periods of feedback loop dominance. So Selden isn't actually doing any of the analysis. Stella's done all of that analysis. You know, you've seen it in the loops panel before 100 times, but it, you know, as you all know, it can be a bit of a pain to sit there in the loops panel and carefully figure out, oh, what loop is dominant now? What, what changed from this period to the next? So we can use the LLM to do that kind of painful, tedious work for us. So what Stella is doing is it's taking that whole LTM analysis that it's showing to you in the LTM panel, it's compacting it into a bunch of machine-readable code, JSON, giving that JSON to the LLM, to Selden, who then takes that information and reorganizes it from machine-readable text into human-readable prose. That's the way that this magic works. The answers are already given to the LLM. We don't ask the LLM for something that it could never realistically know. So in this case, it talks about the population collapse is a classic overshoot and collapse. It's a direct consequence of the interplay between the reinforcing dynamics of the population and the balancing feedback loops related to non-renewable resource. Let's break down the process step by step, focusing on the feedback loops and their dominance. It talks about the initial population growth dominated by R1. It talks about resource depletion and overshoot, which is loops B2, 3, and 4. It talks about the onset, 3 and 4, and the sustained population collapse. These summaries that it puts at the end, I tend to enjoy the most because they really tend to cut right to the heart of the issue. In summary, the population collapse is a direct result of the initial exponential growth driven by R1, leading to the rapid depletion of the non-renewable resource driven by B2. This resource depletion then activates powerful balancing feedback loops 3 and 4 that severely constrain births and accelerate deaths, ultimately overwhelming the population's ability to sustain itself, leading to its collapse. And if we go to the LTM panel, we can see that that is the explanation that all of this information gives, except now we don't have to spend a whole bunch of time going, okay, R1 is dominant to here, then it's B2, then it's. Okay? So that's how we can use Selden to gain understanding for why our models do what they do. From here, I'd like to move to the next step, where we can talk about how we can use AI to critique models. So just like what we did with Selden, where we create a table of all the stocks and flows and key converters and copy and paste them into Selden, we're going to do the same for the critique. We're going to make sure that we've run with LTM, and we're going to be very specific about how we want our critique, and we're going to guide it in what we want critiqued. For instance, give me a critique of my model where for each issue, you generate a bullet point. I do that very often in my prompting, where that bullet point gives a short title of the problem. So I'm now being specific that I want a title and I want bullets. I want up to 2 sentences describing the issue and 1 sentence for describing why the issue is important. I want your critique to focus on the scope of the model and its applicability to the problem statement. Raise any other important issues. The only thing that might be missing from this prompt is an example of the audience for whom I want this prompt for. You know, I want this critique to be given to a climate scientist versus a high school student versus a member of the general public. If you don't specify, it's going to tend to go quite long-winded and shoot kind of somewhere in the middle in terms of the level of complexity of the critique. So we're in Selden. In the assistant-specific inputs, we still have the problem statement. We still have the behavioral description. So I'm going to take that prompt, and I'm going to copy and paste it in so that you all don't have to watch me type. And I'm going to hit submit. And so now we're leveraging the LLM to make use of not only the LTM analysis that is still within the context of Selden, but also the structure of the model, including all of its documentation, units, and equations. So it's going to use not only the structure of the model and its feedback loop dominance analysis, but also all of the documentation that exists within the model to come up with its critique. By asking the LLM to structure the information in a particular format, we tend to get that information back out in an easily consumable way. By default, I've set up Selden to be very long-winded and wordy. If you want Selden to shut up and get to the point, prompt it to do so. It will listen. It will follow that instruction. So it talks about, the limited ecological context. The model currently focuses on a single population and a single non-renewable resource. In my problem statement, I talked about an ecological context. So why aren't there predators and prey and the dynamics of renewable resources? This is a pretty important one. It says, hey, there's an absence of socioeconomic factors. Well, we didn't name our population variable all that well. It's just called population. It doesn't know if it's people or rabbits or foxes or bacteria. It has no idea. In this case, it looks like it's assuming that it has something to do with humans, hence why the socioeconomic factor critique. We could probably write that one off and know that we should change this to be population of critters. It then points out issues with instantaneous resource impacts. There's no delays in this system. Things just change instantly based on what's happening at the moment. And it points out how delays are crucial in system dynamics models. It talks about the simplified resource dynamics, a fixed initial quality that only depletes. And it talks about graphical function assumptions. But it gives us a summary at the end that says, you know what? This model ain't half bad for exploring overshoot and collapse with a non-renewable resource. The shifts in feedback loop dominance, give you key insight into the behavior. And hey, you might want to do something more to better capture that ecological context that you asked about. So this is how we can use LLMs to critique our modeling work. Now, some of you are probably getting a little nervous about, my gosh, these tools can really do a lot. How am I ever going to be able to detect the pedigree of the model that I've been looking at? Well, if you go to Model, Detect AI Usage, you get a full summary report that shows you exactly what parts of the model have been built by a human and built by the AI. The information is organized as who created the element, the AI or the human, and who's touched it. You can see in this case that we've actually built this entire model using AI without the human actually ever taking any steps, changing any equations, or touching any of the documentation. This information is stored in a cryptographically secure manner inside of the model file. If tampered with, this AI usage report will report that tampering. This AI usage report only works in Stella 4.0 moving forward. So if you take a model from 3.8 or 2.0 or some other historical version and bring it in, Stella will not be able to report the pedigree of the model. Likewise, this report is capable of detecting if a student were to, for instance, copy and paste a model from an AI generated context into a non-AI generated model, and will still report that the model was built using AI. Likewise, this log, including both the prompts and the responses, is maintained in perpetuity with the model unless otherwise cleared. If cleared, the Detect AI usage tool will tell you that somebody has been mucking around with their log of AI requests. The other thing I'd like to mention is that all of the tools that I'm demonstrating to you here today are also available in the free Stella Online. So you can make use of them without necessarily buying a license to Stella. So let's talk about the last part of the modeling process, and that is policy analysis. How can we come up with policies using AI? So again, just like we've done in the previous steps, we create a table of all the stocks and flows and key converters and copy and paste them into Selden. We make sure that we run with LTM, and we describe the behavioral change that we're looking for. Give me some ideas for how I could prevent the overshoot and collapse, for instance. And in this case, I wasn't being specific about the way that I want that information. So I'm going to say, give me some ideas about how I can prevent the overshoot and collapse. Give me those ideas in a concise, bulleted list. I want a short explanation of the policy, as well as a longer explanation for why you think that policy may change the behavior of this model. And submit. So now we're, just like we used Selden to come up with ideas about how to build this model in the first place, we're going to use Selden to come up with ideas about how to resolve problems within this model. Likewise, I could have added to this prompt things like, and for each policy, give me a 2-sentence prompt that I could give to an AI to enact that policy inside of this model. So don't ever be afraid to use the AI to come up with prompts that you then give to the AI. Likewise, don't be afraid to use the AI to generate information that you then validate and pass back to the AI. Frankly, reasoning and thinking models, all they're actually doing is that. They are taking output that's never shown to the user, generating it, feeding it back into the process, and then showing you the final output from the system. So in this case, it talked about the overshoot and collapse and all of that. And it said, okay, first policy, reduce birth rates. Implement policies that encourage lower birth rates, such as improved, again, it thinks people, because we never actually corrected the name of population. This policy directly targets and weakens the reinforcing loop, R1, by reducing the birth rate. The initial exponential growth of the population will be slower. Reduce base per capita resource consumption. promote resource efficiency through technological innovation, etc. And this attacks B2. Likewise, implement a proactive resource conservation policy, and it talks about what loops are targeted in that policy. So with that, I want to stop yapping at you. I want to put this on the screen quickly so that you all can take a screenshot and check out these resources. All of these techniques that I've been giving you today, we've been writing about in the AI and SD Education Task Force of the System Dynamics Society. You can go to this link, join the group, and participate in our discussions moving forward. Likewise, every tool that I've shown you today, its implementation is open source in the SDAI project. You can go to that second link there on the right to learn more about those tools and the project and how to get involved there. At this point, I'd like to shift into a discussion where we talk about how AI might reshape your modeling workflow. What are you excited for AI to be able to help you with? What are your concerns about integrating AI into your modeling process? And do you think AI can help lower the barriers to entry to the SD field? Or any other concerns that you want to discuss among this group? Press the raise hand button in the panel in order to be called on by Kareem. Thank you.
Thank you, Billy. As we wait for hands to go up, I do have one thing that you could perhaps explain. You used LLM and explained it was large language model, but you used LTM a lot, but did not ever really say what it was or how I run with LTM.
Sorry. To me, it's second nature. LTM is loops that matter. That is calculate loop dominance information inside of Stella. That's the methods that developed to do algorithmic loop dominance analysis using essentially mathematics to identify which are the feedback processes that are most important for causing behavior within the system, within the model, excuse me. So as long as your model is an accurate reproduction of the system, and that's up to you to decide, then those feedback loops are an accurate representation of reality.
Thank you, Billy. Max, your hand is up.
Okay, now I'm muted. I have a question and maybe an idea that could be interesting with respect to how variables are actually placed by the artificial intelligence and in Stella. I wonder whether you have used the rules that Erling Moxnes came up with for making CLDs look nice. And this can to some degree also be used probably in stock and flow models. I think it's in one of his presidential speeches in one of the conferences.
I said I am familiar. So the AI isn't actually doing the diagram generation. That's not something that language models are very good at. Again, language models are very good at transforming information from one context to another, from prose to equations or equations to prose. Large language models have no conceptualization really of visualization. So what we actually do with SDAI is we generate the model as a network, as a graph of equations. And then each of the clients has their own methods by which they turn that completely non-visual graph of information into a picture. The techniques that I'm using are based on what's called GraphViz, which is a project started at Bell Labs in the 80s, I want to say, that they used, my guess is to plot phone networks, which actually runs a little physics simulation to determine how to place things. And then following from Alling's recommendations about how to emphasize feedback loops, we actually curve the edges around the shortest feedback loops that the edge is a member of, the edge being connector, to emphasize the feedback within the system. That's why the diagrams generated for the CLDs are so much better. because there's less variety in those diagrams because it's only words and arrows. The stock and flow systems are much more complicated because the stock and flow elements have very particular rules in the sysdynamics language. And I actually wrote a paper in 2020 that describes the algorithm for doing this, where I actually generated an entire stock and flow model for Forrester's national model. You can find that on ARXIV. I agree with you. The diagram generation stuff is ripe for improvement. I will call it functional, not good. And as much as we can build on, the experience of Alling and other sysdynamicists who have thought about how to build diagrams, the better these things are going to be. Thank you.
Thanks, Billy. Mike? You could unmute yourself. I think I sent a request to you unmute and then.
How about now?
Yep.
Oh, great. Hey, so Billy, Cream, wonderful work. Excellent. Really pleased with what you've done. Quick question. Can the tool be used to put a model into equilibrium?
I've not tried. My guess is it will suck at it just like us humans suck at it.
Okay. Sarah, you might have to click on unmute as well. Uh-oh, it's not coming through. You're unmuted, but we are not hearing you. Something's not connected on your audio setting for your mic. I don't know what. We can come back if you want to go to audio settings and check that out. Jim.
I think I'm properly unmuted.
Yes.
Good. So I think, so again, sort of magical work. In answering the question about whether it lowers the barriers to system dynamics, I think the answer is yes. To some extent, it transfers the burden from being very highly skilled at creating models and analyzing models to the burden of knowing how to write good prompts and being familiar with AI. Now, because AI is becoming so much a part of what everyday people are using, I think that means that overall the barrier to entry for the population at large is lower. I would note that there's still and not surprisingly a significant need to actually understand system dynamics. I mean, even from low level understanding, what good structures there are, like from the molecules or from whatever, or I forget what you folks call them in Stella.
Assembly.
Sorry. I've gotten so used to
you guys are so excited. What are they called? Assemblies, right?
Assemblies.
To very subtle things like, or not subtle, but central and subtle, like what is analysis? What does it mean to analyze a model as opposed to simply take a model as a prediction, as an opinion and a prediction? So you need to know what is analysis. That it is understanding, gaining an understanding of which loops are dominant at what points in time, and why, both from a technical viewpoint, but also from a prose viewpoint. Although I do note, of course, that that Selden helps a lot with that, but you still have to know, the underlying ideas behind it. So overall, I think that it will lower the barriers, and it requires it requires the system dynamics knowledge that is at the core of system dynamics, in which people in the field have always hoped and have striven that that becomes more diffuse throughout the general population of the country and the world.
I agree wholeheartedly. Switch to this resources for educators because I wanted to show people the group that literally is going public as we speak. Fernando is getting ready to send out the email inviting everybody to join. And here's the first copy of the white paper that talks about how to use these tools based upon the thinking of this group of educators who was involved with creating this first version of the white paper. So I look forward to the participation of you or anybody else who wants to help out in this effort. I agree with you. There are a bunch of new skills to learn in exchange for not having to become as expert in some of the other skills. But the human is still the most important part in this process. And the modeling process itself still hasn't changed. You now just have a little bit more time to focus on at least the parts of it that I think matter the most.
Hey, Billy, Sarah couldn't get her microphone to work, but she typed in her questions. Can you talk about if or how the information you put into the AI is retained or reused elsewhere, and how users' IP and confidential information is respected by the LLM or the engine owners?
Yeah, so you can actually inspect all of the code inside of SDAI and see that absolutely nothing is stored there. So there's nothing that's on any of IC system servers, or in the case of Skip Designed on their servers, that is natively inside the SDAI platform that holds on to information. Now, if you're using the API keys that Stella provides, you are then bound by the same agreement that we are bound to the LLM providers by, which all say that they do not train on the information passed to them. Ultimately, though, this is something based on trust. And the terms of the agreement between IC Systems and either Google. Gemini is the default LLM for each of these engines, but using the experimental versions, you can change that. Now, if you want to provide your own API key where you set up your own privacy settings, you are capable of doing that. But my ultimate recommendation to you is, if you're working on any kind of personally identifiable information or any kind of sensitive information or things like that, I would not use these AI tools. These AI tools only ever communicate with the LLM when you hit the submit button. Stella will actually warn you if your model has never talked to AI before, that you're about to share everything in your model with the AI system. Are you really sure you want to do that? So I understand your reticence and your concern there. So here's, for instance, where you can enter in your own API key if you want to use Google, or if we were to go into Selden Experimental, you could see where you could enter in your own OpenAI key, Google key, or Anthropic key, based on if you are using an OpenAI model, a Google model, or an Anthropic model. In which case, then the agreement will exist between you and the LLM provider, and not at all, you won't be relying at all on the agreement between IC Systems and the LLM provider. But being perfectly frank with you, our agreements with these providers are literally the exact same, user commercial agreements that you get. We don't have any special sway or influence with these folks. Hopefully that answered the question.
Thank you. One last discussion question, Roger.
Oh yeah, thanks, Camille. First of all, can you hear me? Can I just check?
Yes, I can.
Yes.
Great stuff. Look, this is absolutely phenomenal. You and I have spoken on this subject before, Billy. You kindly did a virtual meeting with me some time ago. But where I want to, this stuff has exceeded my wildest expectations, first of all. Where I would want to use this is in the C-suite. So where you've got the issue in the C-suite is you've got people with attention spans measured in nanoseconds. So if you go in there and start talking about causal loop diagrams and the importance of loops, you just get told to wind your neck in and leave because they can't cope with it. But if you go in there with let's define the problem. So in effect, you're framing the problem with that wonderful stuff you did right up front there, Billy. Then suddenly you're speaking their language. So when I'm dealing with these sorts of people, I don't even use the term systems thinking or systemics. I use the term causal stories. I tell them, I just want you to tell me a story as if you're telling a noddy story, which isn't quite as insulting as it sounds with some of these folks, I can tell you. But anyway, that leads me to the key question. You are using the AI agents to put together some very serious causal logic here. And I've always run with the understanding that large language models, AI, large language models, do not do causality. They don't understand causality fundamentally. Correct. They do correlation. Is that still a correct statement? Or
that is completely and totally true. That's why I say when you use AI, you need to cheat. You need to give the AI the answer when you ask it the question. Because all the AI is good at doing is reorganizing information from one format to another. So this was my comment about, how does the AI do a good job of building models? Well, we give it all of the answers to how to build a model in the background knowledge, and we just ask it to transform that information from prose, English, text, paragraphs, research papers, interview transcripts, into JSON, machine readable text that represents equations. The LLM doesn't know anything. All that it's capable of doing is taking information from one format and representing it again in a new format. Likewise, Selden is so Selden-y, cool, because I cheat. I give it all the answers in the LTM analysis. The LLM isn't doing any causal understanding of the model. All it's doing is it's taking this JSON data structure, this machine readable data structure, and turning it from code to English. So that's the way that this magic trick works. That's why your understanding of LLMs as giant correlation machines is still true, even though we can use them to build causal models. Because the causal information is in the background that we give it to work with.
Thank you, Billy. Billy said we can keep going if people are still here. I'm going to try to address some of the questions that are here before we do more discussion.
Yeah, let's read some if there's in the question box.
Yeah, so how can we use these tools to improve the grounding of our models?
Ooh. So this goes back into AI as critic for me. Here, I would very much so guide its critique to focus on the scope and the support for information. So I might feed it, for instance, this is another little trick I didn't tell you. You can actually put a link into a research paper and it will go out and actually read that research paper as a part of it generating a model, or Selden giving an explanation. So what I might do is I might actually pass this thing a bunch of links to a bunch of research papers and ask Selden, based on the content of those research papers, does my model represent reality? So I'm specifically giving it an instruction to ignore anything it's learned kind of in its training, and instead focus on what you are giving it right there, right now. Another way of doing this is actually to use off-the-shelf tools, because the AI tools in Stella don't support RAG, which is uploading of files directly. So what you could do is you could use something like ChatGPT, where you can upload files directly, give it a series of research papers, ask it to summarize the key structural relationships that exist within those papers, validate that summary yourself, then take that summary, copy it, paste it into the background knowledge of Selden, and then ask Selden to do the same thing without having to read all of the papers themselves. The more tight and the more specific that you can be with your background knowledge and your context, the better answer you're going to get out of these tools. So using the AI to kind of do a two-pass, take the papers and distill them into summaries, something that LLMs, Google, OpenAI, Anthropic have spent billions of dollars figuring out how to do well, so they do it actually pretty well. And then using it again in a second pass to compare the summary to the model.
Thank you, Billy. The next question is, what are the risks of using AI throughout the modeling process and in using it to interpret the model results?
Yes, so this is something we talk about in the document quite specifically. You can see it inside of ethical considerations, and you can also see it in terms of risks of AI in SD education. To me, the biggest one is that people shut their brains off and stop actually thinking. To me, the power of Sysdynamics is people's ability to think. That we create people who are capable, or create skills in people who are capable of kind of understanding problems from a real kind of systemic perspective. And there's an opportunity here that if you rely way too much on the tools, that you don't actually get that. You end up just parodying junk around and pretending that you actually know or understand something about the world. But all you've actually done is ask a machine to build you something, not understood it, and then claim that you have. The next is bias. Research essentially shows that tools based on large language models often reflect a systematic omission of perspectives for marginalized populations due to the way that they're constructed and trained. So you want to be real careful that you are not cutting off certain perspectives by making use of these tools. The work of community-based Sysdynamics is as relevant, if not even more relevant than it's ever been before, in an era where information is becoming more and more homogenized. Likewise, there's always the danger of misinformation and model inaccuracy. If you don't do, what I was teaching you to do today, feed these machines the answer and ask it to transform the answer, the information from one form to another, there's a risk that these things just hallucinate their face off and give you a bunch of junk back. As Jim was kind of talking about, if the people who are using these tools don't really have enough skills to determine what's junk and what's real, there's a risk that people go off parodying junk hallucinations because they don't know any better. Finally, there's issues with transparency and interpretability. Building, look at that CLD I made of the causes of the American Revolution. Who's really going to spend the time to pour through that thing after it's been created? You're much more likely, there's a confirmation bias. Oh, a machine built it, it must be good. By building things in smaller pieces, it forces you to become much more intimate and familiar with the structure, with the concept, and therefore actually understand it better. If you try and shortcut using these tools and jump immediately from nothing to everything, you end up building a bunch of opaque garbage that you don't ultimately understand. So you can see that we've been thinking about this. Is this the only set of risks? Probably not, but I hope that it covers the big ones. And boy, would I be glad to interact with more of you inside of this task force. Go ahead, join, get involved, come to our monthly meetings, and let's continue this discussion and conversation.
Thanks, Billy. Someone has asked whether the AI assistant will at some point help build model interfaces.
One day. You can't actually see my hand as I do the one day motion. I'd like to. Is that next on my list of things to do? No. But it is something that I think is possible, but would require a very different set of skills to develop than the ones that I've been honing over the past about year since I started on this process.
Yeah, it's very different. Billy, the next question is, can you repeat again the difference between the regular engine and the mentor engine?
Yeah, so the mentor engines, they ask those mind-bendy, brain-expanding questions. So if we come back here and we look, here's an example of a mentor response. It didn't just tell us how the model was built, like the non-mentor does, but it said, well, have you considered missing scope and model variables? Have you considered that you might be missing some flows? Have you considered this potentially crappy graphical function? Have you considered if your model is giving you the right results for the right reasons? And have you considered what exactly you mean by non-renewable resources? So the mentor is always going to come around and ask you questions. You won't see questions in the non-mentor versions. The mentor versions, though, their system prompt is very much guided and directed towards critiquing and expanding the thinking of the people who are using the tool.
Thanks, Billy. Next is a general question about using AI. Do you have a sense of the energy and water costs of using AI in the process of building SD models? And could we build in an information feedback loop so users can consider that in their decisions about AI use?
No, unfortunately, I don't have any information. Even me as a developer, am completely cut off from anything beyond the monetary costs of using these systems. That's something that if you want to get more information about, you would have to push the people who provide these off-the-shelf tools to provide that kind of information in their API so that I can then take that information and present it back to you. But my thought is we are in a unstable equilibrium here. These tools being based in data centers requiring power plants and, yada, yada, yada to be built. I don't think that's going to last for all that long. I've been using a bunch of the local LLMs, Qwen, DeepSeek, smaller distillates of larger models. And frankly, they are catching up quick. The ability to be able to use these use LLMs kind of on your own machine and never actually have the information leave your own computer, I think is reasonably around the corner. With SDAI, we do actually support models that run locally using what's called OLLAMA. I actually don't know what OLLAMA stands for. Essentially, it's a platform that hosts a bunch of local LLMs. And while the performance definitely lags behind these, I'll call them flagship models from Google, OpenAI, and Anthropic, they're not all that far behind. And ironically, the load of generating these system dynamics models, I actually think is relatively light as compared to something like Claude Code or OpenAI's Codex or other kind of software engineering vibe coding style tools. So I actually think these SD tools will be able to more quickly pull themselves off of the platforms of the big LLM providers and onto locally hosted systems sooner rather than later.
Thanks, Billy. The next question is, if I have the LLM help me, the AI help me build a model, how can I cite its references for the details it found?
So that would be using, in my opinion, the LLM in the wrong way. You don't want to use the LLM to do your research. You want to do your research so that you know where the information has come from. And you want to provide that information to the LLM as background, and then have the LLM build based on that background information so that you can then cite back where information is coming from. Likewise, you can give it an instruction that in the documentation you would like to cite the particular phrase or sentence that is the reason for why this connection exists. And then you can identify where that phrase or sentence came from within the literature that you gave it in the background to develop the parenthetical citation. Don't ask the LLM to write parenthetical citations for you, because then you're going to be like those lawyers who write briefs for judges and then get laughed out of the courtroom when the judge is like, well, that case never actually happened and isn't real.
Great, thank you. And then could we use these AI-assisted model construction and analysis in a team setting? How would we do that?
So there isn't a multi-user interface to Stella. Co-model, a tool built on top of the SDAI platform for qualitative models, does support that. If you want to have multiple people interacting, I would suggest multiple people in front of one computer or multiple people in a Zoom meeting with one person presenting.
Do you think the critique functionality that you demonstrated could be used to peer review models for people to increase trust?
I'm not sure that it increases trust. I actually think it decreases trust a little. But being perfectly frank with you, I haven't used it in the peer review process, but people have sent me models that they've wanted critiques of. I have used Selden to generate those critiques, and then I've gone over the critique that Selden has generated and changed it into my own thoughts and feelings, and kind of using Selden to guide my exploration of the model. And those have been received quite well. So I kind of think that's a pathway that works real well. Use Selden to deal with blank page syndrome. Where do I start? And then verify by hand that Selden isn't just spewing you bullshit. And in the process of doing that, you'll be forced to actually interact with the work and actually review it in a proper systematic manner.
Great, thank you, Billy. We're pretty much out of time, I think.
Sure.
So thank you, everyone, for joining us today. Thank you, Billy, for a great presentation, and I hope you'll join us for our next webinar.
Excellent. See y'all soon.
Bye.
Bye-bye.